So long is a common subsequence too. Previously, we did the first part of this problem. This is a continuation. The difference is now we are talking about a list of strings. We're going to find the longest uncommon subsequence. Previously, we have found like the longest uncommon subsequence of two strings. So the difference is there is a list, and then like by taking an example, right? So the output for the example 1 is 3 because ABA, for example, is a subsequence of itself, but it's not a subsequence of the string CDC and EAE. So that's why the length of ABA is 3. Okay. The second example, we have AAA, which is a subsequence of itself, but we have another AA, which is also a subsequence of the first one, right? So which means AAA is not going to be the answer. So we have two A's, A and A. This is a subsequence of itself as well as AAA. So that's why like we don't have an uncommon subsequence. The answer will be -1. All right. So this question actually I think can be accepted by using a brute force where we can compare each of the string to see whether one string is a subsequence of another, and then find the longest. So that will be accepted by the online judge. So here, like, I have a sort of like a unconventional solution where I try to analyze the problem very similar to where we did the problem 1, and it will be having a perform better for some test cases, for certain test cases. So intuitively, we can see that a list of strings within an array, something like this, right? So from problem 1, we know that if a string is longer than another string, then this string itself will be a uncommon subsequence between these two, because the shorter string never has the longer string as a subsequence, right? So by knowing that, if we try to order them on descending order of the length of the string, like this, for example, and then we first iterate through the strings that has a maximum length, and if we can find a string that is by itself, right? We have, like in this example, we have two ABAs, we have two CDCs, and we only have one EAE. Okay, we know that ABA won't be a uncommon subsequence because we have another ABA which is going to have the subsequence of itself, right? And then there are two strings already have the subsequence, which is not uncommon. So, but on the other hand, if we are able to find one string or some strings that only appear once, then we know that EAE is going to be the answer, because EAE is only a subsequence of itself, but it cannot be a subsequence of the same length string, and it cannot be a subsequence of the length string as well, right? Okay, which is really good. So considering that, what we're gonna do is we're gonna iterate through the strings, and we're gonna store them. We're gonna count them by appearings. Okay, so we're gonna say, okay, ABA appear twice, CDC appear twice. Okay, where is not going to be our answer, but we have a EAE appear only once. That potentially is going to be our answer. If it's a maximum length, then it definitely is going to be our answer. But consider the example of we don't have a string appear only once in the maximum length, and we're gonna continue to scan, and we see an AE in here. AE appear once as the string length 2, right? So like we run out of strings that has length 3, and we further down there to iterate strings that has length 2. So AE is a good candidate, but then we're gonna check if we have something like it's not maximum length, then we're gonna check whether AE belongs to a substring of this, right? So in this case it doesn't, then it becomes our solution, which is 2. So suppose we have EAE in here twice. So here we know that AE is a subsequence of EAE, right? Which means AE, although it appears only once in the length of the two strings, but it won't be our uncommon subsequence. And we can further scan, seeing, oh, there is an XX appear only once, but it's not a it's not a subsequence of all the max length strings. See here, okay? And then XX is going to be our solution. So another note is when we compare, we only have to compare with the unique values of the max string, such as EAE, CDC, and ABA. That's it. All right. So let's take a look at the implementation here. So at the beginning, we're gonna sort the list on a descending order according to the length of the string, and we have a loop. We're gonna loop through the list, right? And so if the length of the string is equals to the previous length, meaning that we are iterating through the second ABA, for example, which is the same length as the previous ABA, we are still in scanning the batch of the strings with the same length, right? So that's where we're gonna count the appearance, and plus counter equals to 1. So that string by count denotes the strings, unique strings with their appearance, right? With this count, right? And now, if somehow like the length of the string is not equal to the previous length, meaning that we are running into a new set of strings with a different length, with a less shorter than previous batch of strings, here we're gonna calculate. We're gonna start to find out whether there is a solution we already found. Because if somehow we can find a string that appears only once, then we know that's our solution, right? So this function is going to do that. What it takes is the count map as well as the maximum length string. So the maximum length string, as I was talking about, is the unique set of strings. It's defined as a set in here. Unique set of strings that has a max length. In this case, it's going to be ABA and CDC. Because that is the only string set, we need to see whether it has a subsequence of the current candidate, right? We don't have to record everything. We can only have unique strings in there. All right, so let's take a look at the implementation of this found sequence. So we take 2, and then as I mentioned earlier, we're gonna iterate through the map and then find if there is a entry has the value of 1, which means it appears only once. So if there is, then we have a candidate. Otherwise, we know that we don't have a candidate. There's no solution within this batch. Okay, so once the candidate, we found something in there is not empty, then we're gonna compare each of the candidate with the unique set of max length strings, right? Okay, in here we have AE, we're gonna compare with ABA and CDC, right? And each subsequence is a helper that find out whether AE is a subsequence of the max length strings. Okay, so if there is a subsequence, then we know it's not going to be a solution, right? Otherwise, we know it is a solution. We're gonna return true. Otherwise, return false. So once we're done with this, if we found the subsequence, we're gonna return the length of the previous length, right? Which is our answer. But if we haven't found the answer, then we're gonna continue to clear out the counter map and move to a shorter batch of strings and redo the same thing over and over again. So we only initialize the max length strings when the length is equal to max length, right? We only initialize this set once at the beginning. And finally, like if we cannot find an answer, we're gonna return -1. All right. So as for the helper in here, it's relatively straightforward. Where we have 2 strings, we're gonna find out whether string 1 is a subsequence of string 2. So if they don't have, if like string 1 somehow is greater, then obviously it's not a subsequence. And otherwise, we have 2 indexes. We're gonna iterate through, and we're gonna try to match string 1 to string 2, and until like if string 1 fully matched with string 2 before string 2 run out of characters, then we return true. Otherwise, we return false.